Yes, hello. My name is Eric Gregg. I funded GM Instruments 25 years ago, and one of the instruments that we've promoted over that period of time is our Rhinomanometer. This has now moved to the NR6 model, and what I'd like to do today is to give you an introduction to it, give you an idea of some of the facilities that are present and some of the fundamentals in terms of making measurements with the Rhinomanometer. Rhinomanometry is an active test. The subject has to breathe while you're making the measurement. So what we need to measure in order to calculate nasal airway resistance is to capture the flow rate through the nose and also the pressure that's generating the flow. In order to do that, we have a mask to collect nasal airflow connected via an antiviral filter to a pneumotachograph head. Measuring flow therefore is very simple and straightforward. What's slightly more tricky is to measure the pressure producing that flow, because it's the pressure at the back of the nose that we need to capture. There are a number of ways of doing this. For posterior rhinomanometry, we can use a tube in the mouth. So we monitor pressure in the mouth at the same time as the nasal airflow produced by that pressure. The disadvantage with posterior rhinomanometry, however, is that the soft palate has to be relaxed at the back of the mouth, and not everyone can do that, certainly not without practice. I think it's generally accepted that something like 95% of the population are, with some training, able to do it, but the other 5% just can never do it. So it needs a bit of cooperation to do posterior rhinomanometry. If you do use posterior, then you can measure both nostrils simultaneously. The more popular way of doing the measurement, though, is the anterior test, where we close off one side of the nose, so one nostril is obstructed and no airflow comes through that, allowing the other side of the nose to produce all the airflow. When the nose is closed off in that way on one side, the pressure we measure at the outside of the nose here is the same as the driving pressure at the back. So we're able to measure driving pressure at the back of the nose, airflow through one nostril to allow us to measure one side. We then have to swap them over. In order to close off one side of the nose and to connect a pressure tube to it, there are a couple of different ways that can be done. We can use tape and a small connector to cover up one side of the nostril, and that gives us a tube that we can connect to a pressure transducer within the rhinomanometer. And that's one of the approved ways of doing it, but it's not so good if you have a moustache. Another way of doing it, though, is to use a foam insert. And we have a range of 3 different sizes of inserts, and what happens with these is that you can roll them between finger and thumb and they become much smaller, which makes them easy to fit inside the nose. So if we connect that to a tube, we're then able to insert that into the side of the nose where there's not going to be any airflow. It does distort that side of the nose, but that doesn't really affect the other side. So that would allow us to measure pressure at the back of the nose while in the mask capturing the flow rate through it. So generally that's the hardware side of things. The system is connected to a computer, and we have the software, which I'll now start up to demonstrate its use. Within the software, you can start with a new patient and enter patient details, or you can open up a file that's already been generated for a particular patient, and all of the test results for that patient are stored in the one file, which means that when you look at previous test results, you can do comparisons either on tests that were done days or weeks or months ago, or on tests that you did earlier on today. At the top bar we have the NR6 acquisition screen. If I click on that, we can see then we have a graph with flow on this axis and pressure on that axis. So vertical for flow, horizontal for pressure. And it's split up into 4 quadrants, so that left side results are using those 2 quadrants and the right side results are using those 2 quadrants, and that's as recommended by the International Standardization Committee. We have the option in the software of measuring a test using posterior technique or anterior left or anterior right. We also are able to change the point at which the calculation is done. Normally with rhinomanometry, when we produce the flow pressure trace, it will cross a fixed point at 150 pascals, and it's at that point that we normally calculate resistance. But if the subject is unable to reach that because they have a very open nose, if they have a very open nose, then a large flow will be produced, but only caused by a very small pressure. It only needs a small pressure to produce a large flow. Therefore, they might not reach 150. If that occurs, then you can change the calculation point to 100 or even down to 75. But typically 150 would be the value that you would use. So we want to measure a rhinomanometry test, do a rhinomanometry test. We have the mask, we have the antiviral filter, we have the flow head, we have our connection to the pressure. So I'm going to do a test now. As with acoustic rhinometry, it's very important that you don't distort the nose. You want to have a minimal distortion of the nose, and you want to have minimal leakage at the nose. So the first thing we're going to do is to roll the foam insert, and I'll test the left side first of all, which means this goes into the right nostril. We don't want any airflow through the right nostril. I need to then connect this tube to the instrument, but before I do that, I should check for leakage. So if you ask the subject to close off with their finger the tube that's connected to the blocked off nose, and ask them just to breathe in and out gently through the nose again, perhaps by closing off that side as well, you can tell, the subject will be able to tell, and you should be able to tell whether there's any leakage there, and if there is, then you correct for it. And once that's sealed, then you can proceed to do the test. Take off my glasses for this. With this tube sitting in this position, on the cheek, the soft part of the cheek, we can actually use the mask to hold it in that position for you. So I'm going to put this onto my face now and connect the pressure tube to the tail end here, and follow on from that to make a measurement. Need to do this as a two-stage thing. Normally you would have the mask on the face, holding this tube in the same position as it was when you checked for leakage, and that way you avoid as much as possible any movement to the tube, and avoid therefore generating a leak. Right. The system is set up to take in 4 respiratory cycles and calculate resistance for that side. So I'm now going to change and do the other side. And what I need to do the same process again. Roll off the foam insert. You may change to another one if you want to, or you may be able to use the same one again. Insert it. We should check for leakage once again. It's not too bad. Connect on the pressure tube. Again, once you've checked for leakage, this tube here that's on my face should ideally not be moved at all, but since I'm doing this on my own, I had to make that change. So again, we're ready to make a measurement. And now, as you can see on the screen, we've got 2 traces. The right side ones, using the 2 quadrants, inspiration right, expiration right, expiration left, and inspiration left. And you'll see that the 150 line has changed colour now. We've split the 150 line into 4 different colour segments: red at the bottom, amber, dark green and light green. And this is to give guidance as to how the test has come out, because if the curve goes through the red sector of the 150, then you have a very severely obstructed nose. If it goes through the amber, then it's slightly obstructed. Go through the dark green, then you're approaching a more normal region, but it is still slightly blocked off. And if the trace goes through the light green sector of the 150 Pascal line, then you have a very open nose. So that gives you some guidance as to what this actually means. In terms of the table of results at the bottom, we give flow rates at the point where the trace crosses the 150 lines, and we give inspiratory flow rate total, expiratory flow rate total, average resistance values, and the difference between the left and the right side. And in this particular example here, there's a 33% difference between the right side and the left being more obstructed. Having completed that part of the test, we can then do a comparison between previous tests. So if I selected, for instance, this one here, and I want to compare it to that one, I can do that directly and create a new comparison test. And you'll see that it's drawn the two sets of results superimposed in different line styles, one of them being solid, the other being dotted. And again, at the bottom of showing the table here, it gives you the percentage change figure. Now what I've done is a very simple set of results there. In addition to doing the standard rhinomanometry, which is basically what I've done just now, we also have the 4-phase facility, which allows you to calculate, in addition to basic resistance values, effective resistance and vertex resistance, and the logarithmic values of those. The logarithmic value, particularly of effective resistance, correlates much better with the patient's feeling of resistance in their nose. So we have the ability to do active anterior or posterior testing. We can use a fixed level of for calculation at 150, or if you select another pressure level at that other level. We can also use the Brom's technique. We can use make standard resistance measurements. We can do vertex and effective resistance measurements as well. So rhinomanometry is an active test looking at nasal function. Its sister instrument, the acoustic rhinometry, offers you a static test looking at nasal structure. So together they are able to provide a total picture on the state of the nose, allow you to measure the difference pre and post operative, pre and post challenge, do an assessment of how effective the nose is working before or as part of a sleep study. And all of those things together lets you have a full picture of what's happening in the nose.